Good morning, children. So far, we have discussed in this lesson the criteria for congruency of triangles as SAS, ASA, SSS, RHS and AAS. In that, RHS and SSS will be in the later on exercises, and the theorem as angles opposite to two equal sides of a triangle are equal, or sides opposite to two equal angles of a triangle are equal. So now exercise 7.2 is based on these theorems. The first question: in an isosceles triangle ABC with AB equal to AC. Exercise 7.2, question number 1. In an isosceles triangle ABC with AB equal to AC, immediately when two sides are equal, angle opposite to equal sides are equal. Which are the angles opposite to it is angle B and angle C. The bisector of angle B and angle C intersect each other at O. The bisector of angle B, that means angle 1 and angle 2 are equal. The bisector of angle C, that means angle 3 and angle 4 are also equal, meet at the point O. Join A to O. Show that OB equal to OC and AO bisects angle A. That means you have to prove that 5 is equal to 6 also. So now the given condition is, once again, triangle ABC is isosceles with AB equal to AC. Given AB and AC are equal, then BO and CO are bisectors. BO and CO are bisectors of angle B and angle C. And what is to prove is, the first condition is OB is equal to OC, and the second one, AO is the bisector of angle A. The proof always starts with a given condition. The first given condition is AB and AC are equal. So the proof starts as, in triangle ABC, AB is equal to AC given. Therefore, which are the angles opposite to it? Angle B is equal to angle C. The reason? Angles opposite to equal sides. And now the word bisector, that means BO and CO are bisectors. Whenever you hear the word bisector, take half angle on both sides. That is, half angle B is equal to half angle C. You are multiplying with half on both sides. What is half angle B? Either 1 or 2. Let's prefer 2. Angle 2. Half angle C is either 4 or 3. Prefer angle 3. Here you can give the reason, since BO and CO are bisectors. If you give the reason, it's very clear. If angle 2 and angle 3 are equal, which is the side opposite to angle 2, OC, which is the side opposite to angle 3, OB, in which triangle? The triangle is triangle BOC. Therefore, in triangle BOC, opposite to angle B is OC is equal to OB. Here you can write the reason, sides opposite to equal angles. Therefore, the result 1 is satisfied. What is the second part of the proof? To prove AO is the bisector of angle A. Take the two triangles AOB and AOC. Can you prove them as congruent, prove them as congruent, then angle 5 and angle 6 will be as corresponding parts of congruent triangles. For the second part, in triangle AOB and AOC, AB equal to AC given. The second point, OB equal to OC proved, and OA equal to OA common. OA equal to OA common. Therefore, triangle AOB congruent to triangle AOC by side, side, side. That means SSS congruency. Immediately, angle 5 is equal to angle 6. CPCT or OA is the bisector of AO is the bisector of angle A. This is question number 1. Question number 2. In triangle ABC, AD is the perpendicular bisector of BC. That means in triangle ABC, AD is a perpendicular bisector, which shows that the angle 1 and angle 2 are equal. At the same time, BD and DC are also equal. That's the meaning of perpendicular bisector. Show that triangle ABC is an isosceles triangle with AB equal to EC. That means you have to prove that triangle ABC is isosceles, or you have to prove AB and AC are equal. So, given is triangle ABC in which AD is the perpendicular bisector, means angle 1 is equal to angle 2 is equal to 90 degree, BD is equal to DC. And what is to prove? AB is equal to AC. It's a very simple proof. Just prove triangle ADB and ADC are congruent. In triangle ADB and ADC, BD is equal to DC. Given condition, again angle 1 is equal to angle 2 is equal to 90 degree. Given condition, and AD equal to AD common. Therefore, triangle ADB congruent to triangle ADC. Take one triangle and check side, angle, side. That means by SAS congruence. Therefore, AB equal to AC as CPCT and triangle ABC is isosceles. Question number 3. Triangle ABC is an isosceles triangle in which altitudes BE and CF are drawn to the equal sides AC and AB respectively. That means triangle ABC is isosceles. From that sentence, AB equal to AC, which proves that angle B and angle C are also equal. The next hint is BE and CF are altitudes. Altitudes means the line which is perpendicular from the vertex to the opposite side. So, BE is an altitude, that means angle formed here is 90 degree. CF is also an altitude, that is also 90 degree. Show that these altitudes are equal. So what you have to prove is the altitudes BD and BE and CF are equal. So what is the given condition is AB equal to AC. That means the triangles are, it's an isosceles triangle. Then BE and CF are altitudes, and then what is to prove is BE is equal to CF. Once you have to prove BE equal to CF, identify the triangles in which BE and CF are the sides, and at the same time we can use the given conditions. So BE and CF are sides. At the same time we must use the condition AB and AC are equal. This has to be used. So which are the possible triangle is ABE. If you select, you can use the side AB, as well as you can select the angle 1. Similarly, if you are taking ABE, pick out the triangle in which CF is an side, that is triangle ACF. You can use the side AC, as well as you can use angle 2, and in both the triangles you can see a common angle, which is a common angle as angle A. So the proof is in triangles ABE and ACF, that means we have to use both the conditions, so pick out the triangles in which those two sides are involved. ABE and ACF. The first condition is AB of triangle ABE is equal to AC of triangle ACF. The second condition is angle 1 is equal to angle 2 is equal to 90 degree. And the third condition is angle A is equal to angle A common. Therefore, triangle ABE is congruent to triangle ACF. Pick out one triangle and see the congruence condition. In triangle ACF, you have used the side AC, you have used this angle 2, as well as you used angle A, which shows that it is any two angles and one side. Therefore, BE is equal to CF as corresponding parts of congruent triangles. That is question number 3. And now question number 4. They are all similar questions as I have explained now. Triangle ABC is a triangle in which altitudes BE and CF are equal. Prove that the triangles are congruent. It's like a converse statement. Number 4. You are given triangle ABC and the altitudes BE and CF, the same figure, but the given condition is BE and CF are altitudes, and it is also given that BE and CF are equal. And what is to prove is, number 1, the same triangle ABE and ACF. Triangle ABE is congruent to triangle ACF, and number 2, by that AB equal to AC. Once you prove these two triangles are congruent, you can say that AB and AC are corresponding parts of congruent triangles. So the same pattern, you just take the same two triangles ABE, only the congruent criteria changes, and ACF. They are altitudes. So you can take angle 2 as 90 and angle 1 also as 90. Now BE and CF are equal and angle A remains the same, common. So the proof as in triangles ABE and ACF, condition number 1, BE is equal to CF. It's given. The word altitude says that the angle formed as angle 1 and angle 2 as 90 degree. Number 2, angle 1 is equal to angle 2 is equal to 90 degree is also given. The same common angle, angle A is equal to angle A common. Therefore, triangle ABE is congruent to triangle ACF by any one triangle. Select ACF. You have taken angle 2, you have taken common angle, and you have taken the side CF, which shows that that is also by AAS. Therefore, AB equal to AC CPCT, or triangle ABC is isosceles. Question number 5. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC. Triangle ABC and triangle BDC or DBC are two isosceles triangles on the same base BC. Show that angle ABD is equal to ABD is equal to ACD. It's a very simple proof. Triangle ABC is isosceles. That means AB and AC are equal. Automatically angle 1 and angle 2 are equal. So what is the given condition? The given condition is triangle ABC and triangle BDC are isosceles. What is to prove? And what is to prove is angle ABD is equal to angle ACD. The proof: in triangle ABC, AB is equal to AC, given immediately angle 1 is equal to angle 2. The reason is angles opposite to equal sides. Similarly, in triangle DBC, DB is equal to DC given. Therefore, which are the angles opposite? Angle 3 and angle 4 are equal. Same reason as angles opposite to equal sides. What can be done with the left hand side of this equation and the right hand side of this equation? You can mark it as equation 1 and equation 2. Adding equations 1 and 2, the left hand sides will be added, right hand sides will be added. Angle 1 plus angle 3 is equal to angle 2 plus angle 4. What is angle 1 plus angle 3? That is the total angle ABD is equal to, what is angle 2 plus angle 4? That is total angle ACD. Question number 6. A very important question for the examination. Triangle ABC is isosceles with AB equal to AC. Triangle ABC is isosceles triangle with AB equal to AC. The second condition, side BA is produced to the point D. Side BA is produced to the point D such a way that AD and AB are equal. That means AB length and AD length are also equal. Length are also equal. Prove that angle BCD is a right angle. That means angle BCD is a right angle. You have to prove. So the given condition is AB and AC are equal. AB and AD are also equal. And what is to prove is angle BCD is equal to 90 degree. And now let's take angles as 1, 2, 3, 4 for an easy purpose of writing the proof. The proof starts with the given condition of AB equal to AC. which triangle it is. In triangle ABC, AB is equal to AC. Immediately, opposite to AB is 2 and opposite to AC is 1. We will write it as angle 1 is equal to angle 2. The reason is angle is opposite to equal sides. Now, also it is given that AB is equal to AD. Let's take both the conditions again. AB equal to AC. Also AB is equal to AD. Let's mark it as equations 1 and 2. Both the conditions are given. From there, you can write, therefore, AC and AD are also equal. That means AC and AD are also equal. In triangle ACD, AC is equal to AD. Therefore, what is the condition? 3 is equal to 4. The same reason as angles opposite to equal sides. Consider the triangle BCD. In triangle BCD, apply angle sum property of triangle. Angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 180 degree. The reason is angle sum property of triangle. Angle 1 and angle 2 are equal. Either you can choose angle 1 or angle 2. Let's choose angle 2. That means twice angle 2. Angle 2 plus angle 2 is twice angle 2. Similarly, since 3 and 4 are equal, you can choose either 3 or 4. We will choose angle 3, or it becomes twice angle 3 is equal to 180. Twice angle 2 plus angle 3 is equal to 180, or 2 plus 3 is equal to 90, which shows that angle BCD is equal to 90 degree. It's an easy proof as well as a very important question for the examination. Question number 7. Triangle ABC is right angled at A and AB is equal to AC. Triangle ABC is right angled at A and AB and AC are equal. Find angle B and angle C. Can you say it orally? The answer is 45 degree each. Let's find out. What is given here? Given is angle A is equal to 90 degree. What is to find? Angle B and angle C. By the method itself, let's proceed by the method. In triangle ABC, AB equal to AC, therefore opposite to AB is angle C and opposite to AC is angle B. Therefore, angle C is equal to angle B. The reason is angles opposite to equal sides. That means angle B and angle C are equal. Let's apply angle sum property. In triangle ABC, angle A plus angle B plus angle C is equal to 180 degree by angle sum property of triangle. Angle A measures 90 degree. Both angle B and angle C are equal. So any one you can choose as twice angle B is equal to 180 degree, or you can prefer as x degree. Twice angle B is equal to 180 minus 90, which is equal to 90 degree, or angle B is equal to 90 by 2, 45 degree. Now, since angle B and angle C are equal, both of them is equal to 45 degree each. Eighth question is, show that the angles of an equilateral triangle are 60 degree each. That means, given that ABC is an equilateral triangle, given triangle ABC is equilateral, which shows that AB equal to BC is equal to AC. That means in an equilateral triangle, all three sides are equal. And you are asked to prove that the angles are also equal and each measures 60 degree. So what is to find or to prove is angle A equal to angle B is equal to angle C is equal to 60 degree. So the proof, let's take two sides at the same time. In triangle ABC, first take the pair AB and BC. AB equal to BC, therefore, if AB and BC are equal, opposite to AB is angle C and opposite to BC is angle A. Therefore, angle A equal to angle C, the reason is angles opposite to equal sides. Similarly, take the next two sides, BC and AC. BC is equal to AC given. So what are the sides opposite to BC? Angles opposite to BC, angle A, and opposite to AC is angle B. Angle A is equal to angle B, the reason as above. Again, take the next two sides also. Similarly, AC is equal to AB. Opposite to AC is angle B and opposite to AB is angle C. That is, angle B is equal to angle C. Mark it as 1, 2 and 3. From 1, 2 and 3, you got angle A is equal to angle C, angle A is equal to angle B, and angle B is equal to angle C, that is A equal to B equal to C. And now by angle sum property, but angle A plus angle B plus angle C is equal to 180. Since all three angles are equal, you can choose any one angle as 3 times angle A is equal to 180 or angle A is equal to 180 divided by 3, 60 degree. Therefore, angle B also 60 degree, angle C also 60 degree. Even though we know the answers, try to present the answer using the theorems you have learned.